Hello, Honors Algebra 2 students. Mrs. Fallon here. We are talking about graphing sine and cosine and even tangent functions. So let's go ahead and get started. You're probably going to need some extra paper because we're going to do some extra graphs that are probably not on the student journals. So I am going to start though on page 259 of your student journals. So if you would join me there, that'd be great. All right, so first and foremost, what we need to kind of talk about are some of the components of what makes up a graph of a sine function. So I don't know if any of you have actually graphed a sine function, but let's go ahead and look at it real quick on your calculators. So the first and foremost, all right, so let's go to your y equals. Let's just graph a basic sine function. So you hit the sine, and then you hit x, and then you hit graph. All right, so I've got my window kind of set up, wrong, I guess. So let me go ahead and change that. And I'm gonna go zoom 6, which gives me kind of a standard window, right? All right, so on this one, what you'll notice is that sine function doesn't look real great. And the reason why is because when you graph a sine function, we graph in radians. So what you're going to want to do, anytime you want to look at the graph of a trig function, you want to go to mode and see how, remember how we were in degree mode? We want to change to radian mode. And now if I hit graph, you will see a prettier looking graph. So what's special about a sine function? So there's a sine function. I will graph a cosine function, so cosine of x. And that one's in red here, you can see. Notice that they're very, very similar. One's just kind of a shift of the other one. We call this a periodic function. In other words, what it means is that a pattern repeats. So like, for example, down here where it says periodic function, what we are talking about here is a repeating pattern. So a trig function, cosine and sine especially, have this oscillating, this wave, right? And it goes on and on and on and on forever. To be honest with you, if we took the red graph, right? If you zoom in on here a little bit, if you took the red graph and just shifted it, it would be on top of the blue graph, which implies that that one function is a shift of another, right? So they're just kind of staggered a little bit, if you will. So what we mean by amplitude of a graph is if you look at your sine function, there's definitely, or a cosine function, there's definitely a min and a max. So kind of like we did with the, maybe even like a quadratic where we had like a lower value, right? So like that U-shaped graph had a minimum on it. And when we graphed it, there was like a specific vertex or a specific minimum. Similar here, but we kind of a max line and a min line. So like your graph is only going to exist between, this top part and this bottom part. We call that distance the amplitude. So what I'm going to do here is I'm going to go ahead and sketch kind of a picture of what your graph would look like, just so that we can kind of label some stuff. Okay. Again, I'm just sketching, so nothing too major, but all right. So I'm just going to graph kind of an exaggerated sine function. So this is a graph that goes on forever and ever and ever and ever. And so a couple things I want you to point out. So number one, there's going to be a max kind of line and a min line. And so your whole function exists between those values there. What an amplitude is if you take a look at your graph, I'm going to go down here to where it says midline. If you take a look at your graph, when you graph a sine function or a cosine function, there's kind of this imaginary line through it where like half the function exists above the line and half the function exists below the line. I call this imaginary line because this is not an asymptote. This is not anything really part of your graph itself. It's this imaginary line that kind of cuts our function in half, okay? And the reason I'm showing you this is because the distance, we call this the midline. The distance from the midline to the max, or the midline to the min is called our amplitude. So it's the distance, and this is what I want you to write down here. So it's the distance from the midline to the max, so that max value, or it's the distance from the midline to the min. Same thing. So it's this distance here or this distance here, and it should be the same. Mine's not really 100% perfect, but you know. So like if this were 1 and down here was -1, my amplitude would be 1. So the midline's at 0, my max is at 1, the amplitude would be 1. Okay. Next, so the next thing I want to talk about is a little bit about like what the cycle is. The cycle is the pattern itself that repeats. So each function, sine and cosine, has its own little pattern. And we'll talk about tangent here in a bit, but each function that, like sine and cosine, has its own little pattern. Like for example, normally we look at the pattern for sine and we look at it kind of going this direction. So it goes from here, goes up, comes back down to the midline, goes back down to a min, comes back to the midline. And then it repeats over and over and over again. So a cycle is, I guess, the part of the pattern that repeats. So it's the part of the pattern that repeats. What's special about a sine or a cosine function is that a sine function always kind of repeats in the same pattern. So a sine function will always kind of have that same repeating pattern. It'll start at a midline. So this is kind of the what I write down. It starts at a midline. It goes up to a max. Okay, so like up here. And then it goes back down to a midline. And then down to a minimum. And then back to a midline. So it goes through these 5 points. Okay, it goes through those 5 points before, that's its cycle, and then it repeats over and over and over again in both directions. And so this is what we call the cycle of a sine function. Midline max, midline min, midline. And then again, like I said, it repeats over and over and over again. A cosine function is very similar. I'll write cosine down here. So a cosine function is very similar, except if you remember, when we looked at the cosine function, let me just show you on here. I'll just go and look at the cosine function. I'm going to change my y scale so it's a little bit, so you can see it a little bit better. All right, so this is your cosine function. So notice that the cosine function, if you're looking at the origin, it starts at a max. Then it goes to a midline, then it goes to a min, then a midline, then a max. And so the cosine pattern is a little different than a sine pattern. So a cosine pattern will start at a maximum point, then go down to a midline, then a minimum, back to a midline, and then finally end up back at a max. So again, max, midline, min, midline, max. And then it repeats it over and over again. Max, midline, min, midline, max. And so over and over again, that's the cycle for a cosine function. So we're going to talk a lot about these when we graph these by hand. This pattern, this cycle, is going to be really important. And what we call these are the 5 key points. So basically, those are the 5 points I want us to graph on a grid. And so when we graph these by hand, these are the most important points that we have. All right, so in a cycle, what happens is so the cycle is kind of like the pattern that it travels, right? So like we talked about the pattern that it goes over and over again. The distance it travels in one cycle. So I'm gonna write this down. So a period, which is kind of weird, the distance the function travels, and I'm gonna put in parentheses on the x-axis, so we're talking about the distance on the x-axis, in one cycle. So for example, the period for this sine function that I have up here starts here, goes up, comes back down, it ends here. So this distance right here would be considered one period. So it's the distance, like basically the distance on the x-axis for one complete cycle of your graph. And so there's a formula that we use to represent how to calculate the period of a function. So I'm going to have you write this down. The formula is 2 pi divided by b. And so I'm going to show you kind of where all that's going to come from here in a minute. But that's the formula to kind of measure the distance the function travels on the x-axis before it starts repeating again. So it's like one cycle and then it starts repeating, one cycle and then it starts repeating. What I need you to write down for the rest, a phase shift. We're going to talk about shifting our graphs left and right. So for whatever reason, we call this horizontal translation of phase shift. So I just want you to understand that it means the same thing. So when you shift your function, just like we did with logs and logs and exponentials, or even any of those functions that we've talked about in the past, it has kind of the same deal. And this is just shifting it left and right. So the horizontal, so you can think of it as left and right shift. And so we're going to talk a lot about that. All right, finally the midline. And if you want to write something down here, I would just say it's the halfway line. It's not part of your graph. I always draw it in my graph. I'm going to draw it by hand, but it's not something that I require you to have like as part of your actual graph, because you won't see it. Like if I graph a sine function, you won't see a midline drawn in there. It's not like an asymptote or anything like that. All right, the other thing I want to kind of go over is, so this whole 2 pi over b, you might be thinking to yourself, well, what is b? And so I want to kind of go over the standard form for your trig functions. I'm just going to write them down here. So this is kind of remember how we did like a standard form for an exponential function, a b to the x minus h plus k, or a log function, or quadratic, or any of the other functions we've talked about. So a trig function has the same characteristics. Okay, so there's an a value, and what we're going to want to know with this is that this a value is actually going to be our amplitude. So remember, the amplitude is how far up from the midline we go or how far down from the midline we go. It's like that halfway distance. So it's the distance on the y-axis. Your b value is what helps determine the period, which remember is distance the function travels on your x-axis in one cycle. So that's what those a and b represent. And then the h and k are going to represent the same thing they have done in every other function, which is shifting left and right and shifting up and down. So you can have a sine function, you can have a cosine function that does the same, and then you can even have a tangent function that we haven't really talked about yet, but we will get to. So they all kind of have this same generic equation. What I want you to also know, just kind of like a when we did log functions or when we did exponentials, you might have noticed that like the h value, for example, in a log function was your asymptote, and the k value in an exponential function was your asymptote. Well, the k value in your trig functions are going to be your midline. It's less true for a tangent function, but we'll get to that in a little bit. But so the k value is kind of where your midline is going to be. That's your halfway point, right? So it'll help us when we're drawing these graphs to have that information. All right, so what I'm going to do now is we're going to graph some by hand, and I'm going to kind of walk through the steps I would take to graph a bunch of these functions. So if you would please grab some paper, and we're going to graph a whole bunch of functions. All right, so I'm going to start with something basic. We're just going to start with the boring basic sine graph. So we call this our parent function, right? So there's no shifts, there's nothing fancy. There's no a's, there's no b's, or at least they're one, and then the h's and k's don't exist. All right, so I'm going to, on the side here, I'm going to write down the steps I would take to graph these functions. Now, eventually you're just going to be able to do it on your own, but in case as you're kind of preparing, these are the kind of things I want your brain to walk through as you graph your function. So step number 1, I want you to find the period of your graph. So remember, the period of your function, we use a formula for that, right? So the period of your function, the formula is 2 pi over b. And that's how we calculate the period, or that distance on the x-axis. So for this graph, I'm going to go ahead and graph. I like to do these on regular paper, not graph paper, just because I like to not be limited by the squares. So this is one of the few times that I actually graph these without graph paper, but you can do whatever. So the first thing I'm going to do is graph or find the period of my function. So I'm going to write 2 pi over b equals. All right, so remember, what is b in our equation? If you remember back to what I just showed you with our generic equations, where'd I go? So b is that number that's being multiplied by x. So in this case, the b value is the number of the coefficient on x. So in this case, it's 1. So 2 pi over 1 is 2 pi. All right, so why is that useful? Well, step number 2 is you're going to label your x-axis. And we're going to label it with 5 key points. Remember, I talked about those in the last page. So 5 key points. So here's how you do it. Are you ready? Here we go. We're going to start at the origin. So we're going to put that 0. Whatever you have for the period, so in this case, we found that the period is 2 pi. Pick some distance, and this is where, if you want your graph to be teeny tiny, you would pick a small distance. If you want your graph to be a little bit wider, which I encourage, so you can see it better, pick a longer distance. So pick some distance on your x-axis and label it as 2 pi. So what I want to understand here is that one whole cycle is going to fit between this from 0 to 2 pi. Because remember, that's what the period is. It's the distance on the x-axis the function travels in one cycle. So how do you figure out your 5 key points? All right, so now we got the kind of the start and the end. Find the halfway point. So what's halfway between 0 and 2 pi? Pi. And then find the quarter points. In other words, what's halfway between 0 and pi? Pi over 2. And what's halfway between pi and 2 pi? Well, if this is 1/2, this is 2/2, this would be 3/2. These numbers should look familiar to you. We call those our quadrantals. So what we did on the unit circle, like evaluating, sine of pi over 2 or, sine of 3 pi over 2, we're going to translate that now to the graph. All we were really doing there is finding values, kind of like an x and y value, a coordinate point on your graph to be able to sketch your function. All right, so once we've labeled the x-axis, step number 3 is to sketch your midline. So I always do this part. Now again, do you have to? No, but I always do this part. So your midline is your k value. So if you remember, I'm just going to write down in parentheses k. So your k value in this particular problem is 0. So I'm going to use a green marker here. I'm just going to put a dashed line right at y equals 0. And again, you don't have to label it. You really don't even have to include it on your graph, but I like to just because it gives me a good, visual of what I'm actually graphing. All right, if you do the midline, step number 4 is you're going to find the amplitude. I'm just going to abbreviate it as amplitude and label the y-axis. So we're going to use the amplitude to help us figure out the scale on the y-axis. All right, so remember, your amplitude is your A value. That's out in front here. So there is no number out in front, which in other words, it means it's 1. So my amplitude is 1. So this is where the midline comes in handy. So if you are given your midline, the amplitude is the distance from the midline. So the distance from the midline to the max. So pick some distance. Again, maybe pick a little bit. Don't make it too small, otherwise it'll be too cramped. And then try to pick the same distance below. So again, the amplitude needs to be 1. So the distance from the midline to the max needs to be 1. Midline to the min needs to be 1. That's all I really need you to do to graph on your x or on your y-axis. I just really need to know where the maxes and the mins are going to be. So, and this whole function is going to lie between 1 and -1. All right, number 5, apply any shifts. So we haven't done those yet. So that would be if you have like an h or a k value. So like if you had an h or a k value, you would apply them now, and we'll do a couple where we actually do have those. And then last but not least, number 6 is we're going to use our pattern. So remember the pattern we talked about with the sine function, like it goes midline, max, midline, min, midline, or cosine function, which is max, midline, min, midline, max. Those patterns that we talked about on the other side. We're going to use that pattern to get your 5 key points. All right, so let's graph this. So a sine function, that's what we have here. This one is the one, the pattern is midline max, midline min, min. So if you want to write it down, that's great. If you don't, you don't have to. All right, so that means these are my 5 key points. Those are the only points I'm going to have you graph. So we're going to start at a midline. Okay, we don't have any shifts or anything like that. That's going to be your first point. The next point, which is at pi over 2, is going to be at a max. Okay, that's why we label this axis the way we do. The next point is going to be at a midline. So at pi, it's going to be at a midline. The next point, which is 3 pi over 2, is going to be at a min. And then finally, the last point, which is 2 pi, is going to be at a midline. Be careful the way you draw this. This needs to look like one smooth, continuous curve, okay? We're not connecting it with jagged straight lines. It's not linear in between here. These are all nice, smooth curves. So your graph should look like a nice, smooth curve. Notice that I put arrows at the end because it implies that the function goes on forever. So please make sure that you're recognizing this is not just a finite graph. This is an infinite graph. All right, before we move on to something else, I want to talk about one more thing. These lovely points off of your graph. So what we did here, I just want you to make the connection between this and the unit circle. So what we did here is we picked x values of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those were those 5 key points that we picked, right? So we followed this pattern and we recognized the midline max, midline min, midline, and so we can kind of graph those. But what we're actually doing here is we're evaluating. So what I mean by that is so when we plug in 0, that means you're taking the sine of 0. So think back to your unit circle, okay? At 0 degrees, this is the point 1, 0. What is your sine or y value at 0? You get 0. So that's why we have the point, and I'll just write it as a coordinate point over here. That's why we plot the point 0, 0 on your graph. Same thing with all of these. If I did sine of pi over 2, so again, pi over 2 is at the point 0, 1. Well, what is sine or y at pi over 2? It's 1. So that's why we have the point pi over 2, 1. Pi over 2, 1. And then we can do this for all of them. Sine of pi would be negative 1 comma 0, so that would be 0. So that's why we have pi comma 0. That's why it hits the midline there. It's an x-intercept. Sine of 3 pi over 2 would give me 0, negative 1, so that would be at negative 1 for our y value. So that would be 3 pi over 2, negative 1. So that's why we have that point. And then finally, all full circle around, sine of 2 pi is going to give me 0. So at 2 pi, I have 0. So again, all we're doing here is we're kind of translating all those points to those evaluating that we did on the unit circle, and we're translating them to a point on our graph. That's all we're really doing. All right, let's graph some more, okay? So I'm going to let's graph a basic cosine function just so you guys can see it, and then we're going to graph some other stuff. All right, so let's go ahead and I'm just going to turn my paper over and we're going to graph y equals cosine of x. The pattern or the way you graph this function is the same as the way we graph a sine function. So those steps that I just outlined are the same deal. So start by finding the period. So 2 pi over b. Well, in this case, my coefficient or my b value is 1, so that means the period is 2 pi. Now, I know in these two examples, the period has been 2 pi. It doesn't always have to be, but in these two examples, they are. All right, so remember, you pick a distance, label the halfway point, the quarter point, and the 3/4 point. Okay? You might want to graph your midline now. So remember, your midline is your k value. So that's going to be at 0. And then we're going to use our amplitude and we're going to figure out the min and the max. So our amplitude is our a value. So in this case, it's 1 again, just like it was with sine. So I'm going to put 1 and I'm going to do negative 1. All right, the only difference between a sine and a cosine function is that pattern that we recognize. So there's no shifts on this function. So the next thing I'm going to do, instead of starting at a midline with a cosine function, I start at a max. So cosine, it goes max, the next point's at a midline, the next point's at a min, then a midline, then a max. Again, you are graphing a continuous curve, all right? Notice that this cannot, don't just put this on going up forever, because this is the max, right? That is the max that function can go. So it needs to bend and curve back over. So yours should not look like a parabola that goes on forever. So please make sure that you're graphing those correctly. Again, if you want to kind of see the connection between this and the table, all we're really doing here is we're saying, okay, when x is 0, what do we get for cosine? Well, cosine of 0, so again, think of your unit circle. Cosine of 0 is your x value at 0. That's how we got 1. That's why this starts at a max. Because when I plug in 0, which is obviously at my origin, I would get an output, or a cosine of 0 is 1. So that's why we start at a max. And then you could go through the whole thing, like pi over 2, cosine of pi over 2 would be, x value would be 0. So that's how we get pi over 2 comma 0. So my point is all of these, again, are related back to that unit circle. All right, let's graph some that have a little different stuff in it. Let's have a little bit more fun, okay? So now I'm going to graph a couple that have, let's change the amplitude, let's change the period. So let's graph 3 cosine of 2x. Let's add some numbers in here. All right, we do this the same way. Let's start with a graph. First step, if you remember, find the period. So 2 pi over b. What number is b in this problem? If you answered 2, you are correct. So 2 pi over 2 reduces to pi. So how this is going to be important is now this cycle, think about the distance on the x-axis. It's now, instead of going from 0 to 2 pi like the parent function does, it goes from 0 to pi. So it's going to repeat that cycle faster. So it's every pi, it's going to repeat that cycle. So if you were to graph this function as opposed to cosine of x, you would see 2 cycles within 1 period of your parent function. All right, so again, start your distance. So 0 to pi is 1 cycle. Halfway would be pi over 2. Half of a half is pi over 4. If you have a hard time figuring out what this fourth or that third point is, think about what your scale is on your x-axis. You're counting by 1/4 pi. So this is 1/4, 2/4. This would have to be 3/4. 4/4, 5/4, 6/4. And it goes on forever and ever and ever. All right, sketch your midline. So my midline is right here at the x-axis. And then I'm going to use my amplitude to get my min and max. So 3, -3. So again, from the midline to the max is your amplitude, and from the midline to the min is your amplitude. Since there are no shifts, the only thing we have to do now is follow the pattern for cosine. So remember, cosine starts at a max. So my first point at 0, I always kind of start with 0, 0, starts at a max. My next point's at a midline, next point's at a min, midline, max. Oops. Again, nice, smooth, continuous curve that doesn't go past our max or min. It looks like that. Okay, let's keep going. Let's graph one that has a reflection. We haven't talked about that yet. So let's graph -2 sine of x. Okay. Start off the same way. Let's find the period. So 2 pi over b. B is 1 in this problem, so 2 pi. So this is going to be this is kind of like your standard scale, if you will. Those are those quadrantals that we're used to on the unit circle. Again, doesn't have to be this as the other example showed, but that's a pretty standard scale for your x-axis. All right, let's graph the midline. So I probably should have mentioned this earlier, but I'm going to mention it now. So the amplitude is always, the amplitude is always the absolute value of A equals the amplitude. It kind of is implied, right? Because the amplitude is a distance, and can the distance ever be negative? No. So when we look at this, especially with the reflection in front, that's what this negative does, is like that vertical reflection, right? So the amplitude, the absolute value of -2 is 2. In other words, it means that my amplitude is 2. So again, amplitudes are always positive. All right, so the only difference here, what does this negative do? So remember, if we had a sine function, let's go back to my calculator. Oops. Let's say I have a sine function, okay? So it starts at a midline, goes up to a max, midline, min, midline, over and over and over again. Let's graph a negative sine function. So I'm going to throw a negative sine of x. Look what happens. So zoom in right on the x-axis. So normally we would go midline max. What happens? It goes midline min, midline max. So every max now becomes a min, and every min now becomes a max. So again, we're just reflecting it over that x-axis. So the midline doesn't change, right? We're reflecting over the midline. So that the only thing that's changing is our mins and our maxes. So for a sine function that's reflected, we would still start at a midline. So this is a negative sine function. We would still start at a midline, but instead of going to a max first, we would go to a min first. So midline min, midline max, midline. So again, I want to reiterate, the only difference here is that when you're graphing a function with a reflection, the mins become maxes and the maxes become mins. So again, on here, I would go down to a min first, then a midline, then a max, then a midline. Again, a sine, nice smooth curve, goes on forever, looks like that. All right, let's graph some more, okay? Let's add some H's and K's involved in here. All right, let's do some different stuff here. Let's do y equals, whoops, I'm gonna change my pen. So y equals 3 sine of x minus pi over 2 minus 3. That looks like fun, right? So I'm going to do two examples of graphing sine and cosine functions with some shifts. We are not getting into tangent today, as you can tell, because that's for another video. So we'll wait a day on that one. All right, we do this with the shifts the same way we do with our regular functions. I'm going to go ahead and start by drawing my sketch for my grid. I'm going to start by finding the period, 2 pi over b. So when you have an h value here, the b value is still the number being multiplied by x. Generally, it's factored out, and if not, you would have to factor it out. So that b value is kind of your horizontal stretch and shrink, right? That's what that b value does. It changes the values on your x-axis. So in this case, it's 1, so it's our standard 2 pi. So we've used this scale quite a bit, so we're going to go ahead and put in our x-axis scale. Next step is your midline. So remember on this, our midline is our k value. So this is your midline. So what we're going to do, I'm going to extend this down. I'm going to go 1, 2, 3. This is where my midline is going to be, at -3. So we're shifting the whole function down. Again, the midline is that imaginary line, but I really think it's helpful to draw it in there. Once you have your midline, use your amplitude, so my amplitude is 3, to figure out where the max of my function would be and the min. So if this is my amplitude if this is my midline and my amplitude is 3, then the max has to be up here at 0, and the min needs to be down here at -6. So that means my whole function needs to fall between 0 and -6. All right? So again, that amplitude is the distance from the midline to the max and the midline to the min. So we're just kind of setting up parameters for our function. All right, everything else kind of stays the same. We've done everything. The only thing we're going to do now is we're going to shift it. So normally we would take a sine function. We would start at our midline. Remember, our midline got shifted down, so that's okay. However, we also have an h value. So before we start doing our pattern of midline max, midline min, midline, we need to shift the function to the right pi over 2. So my first point, pi over 2, is going to be at the midline. Then the next point, which is pi, is going to be at a max. The next point is going to be at a midline. The next point is going to be down here at a min. And we need to add in one extra point here because we shifted it, and we're going to be back up to a midline. So it still goes midline max, midline min, midline. We just shifted it. We started over pi over 2. We just started over 1. So normally this is where we'd start, but because of the h value, we started it over. And so again, it's a sine function with a nice smooth curve. Looks something like that. That would be one cycle or one period of your function. Please adjust your scale. So if this is 1/2, 1, 1.5, 2, this is 2.5. So I always think of it as 1/2, 2/2, 3/2, 4/2, 5/2, like that. So adjust your scale, add in that extra point, make sure it's labeled there correctly. And that's how you shift a function with h's and k's. Let's do one more. Let's do a cosine function so you can see another example. So y equals, let's do cosine of pi over 4, x plus 2 plus 1. All right, so I added that horizontal stretch and shrink, right? So I added that horizontal, it's going to be a stretch. And then I also added an h value and a k value. Okay. Start off the same way. We find the period. So this one's a little bit different, right? So the b value here is pi over 4. So what's 2 pi divided by pi over 4? Okay, you need to know how to do fractions, right? So 2 pi over 1 divided by pi over 4 is the same thing as saying multiplied by 4 over pi. And so my pi's would cancel. I will get 8. So maybe up until now you thought that radians or your x-axis could only be something to do with pi. And that's not true. A radian does not have to have a pi in it. Remember, pi is just a number anyway, right? So we can have 8 radians. So think about where 8 radians would be on your unit circle. If 2 pi is one whole revolution, and 2 pi is about 6.28, 8 radians would be over one revolution, okay? So we're going to do the same thing we did before. We're going to label our x-axis. So we're going to start with 0 and I'm going to put 8 over here because that's the end of one cycle. Do the halfway point, the quarter point, and the 3/4 point. So basic counting by 2s. Fantastic. Next, let's do the midline. So there's a k value, if you hadn't noticed, plus 1. So our midline gets shifted up. All right. Let's use the amplitude to figure out our max and our min. Well, the amplitude is 1 here, so my max is going to be at 2 and my minimum is going to be at 0. So my whole function is between those two lines. Those like kind of imaginary maxes and min lines. All right, let's graph our function. So again, before we could go ahead, normally a cosine function starts, it goes max, midline, min, midline, max. But we're not going to start up here at the max. We have to move left 2. So I'm going to add in another point here. So left of my origin. So I've added in the -2. And so normally I would start at a max here, but I'm shifting it back 2. So back 1 kind of jump. And that's going to be where I start my max. My next point, which don't forget 0 is your next point. So 0 is going to be at your midline. The next point, which is 2, is going to be at my min. Remember, the whole graph is between 0 and 2. Then the next point is at my midline, and the next point is at my max. So we took the normal function, goes max, midline, min, midline, max, and we shifted it to the left 2. Again, this is a cosine function, so make sure you draw in your nice, smooth, curved lines. All right, there is some additional practice on, well, obviously on big ideas, but also in your book. I don't like the grids here, so I always do this on a separate sheet of paper, but you are welcome to try some more just to get some practice. Again, this is kind of a long video, but tric's important, so unfortunately, we're going to have to deal with it. If you have any questions for me, bring them to class or bring them to your teacher, and practice graphing. Practice, practice, practice. All right, bye for now.